Hello, and welcome to this example on determining net income and volume to break even with increase of fixed costs. We have the following problem. The manufacturer of ovens sell them for $1,780 each. The variable costs are $760 per unit. The manufacturer's factory has annual fixed costs of $2,275,000. There are two parts. Part A. Given the expected sales volume of 4,800 units for this year, what will be this year's net income? We need to express the answer with the positive sign for profit or negative sign for loss, rounded to the nearest cent. B. How many units must the manufacturer produce to break even if the fixed costs increased by 25%? And we need to round up the answer to the next whole number. To work with a problem like the one we have here, we need to understand the role of various variables. The first variable I would like to talk about is the selling price per unit. The selling price per unit is denoted by P and it is the amount a business charges its customers to buy a single unit of item produced. Here P is $1,780 because the manufacturer sells ovens for $1,780 each. The next variable I would like to talk about is variable costs. Variable costs per unit, or VC in short, are costs that have to do with producing one unit of an item. Examples of variable costs are materials, cost of labor, and revenue-related costs such as sales commission, royalties, etc., that are necessary to produce one item for a specified period of time. Here the variable costs are $760 per unit. Then we assume that the total variable costs that are associated with producing a number of units equals the variable costs multiplied by the number of units produced and sold. The total variable costs vary directly with the number of units of items produced, and it varies according to this formula. So we have 760 multiplied by Q, where Q is the total number of units produced and sold. Okay, the next variable I would like to talk about is fixed costs. So we have fixed costs, or FC in short, and those are costs that remain the same regardless of the number of items produced to sell. Here, fixed costs are given by $2,275,000. Fixed costs are calculated for a specific time period and are based on the production of a predetermined quantity of products for that period. Examples of fixed costs are administrative salaries, rent or lease of a facility, utility costs, insurance costs, property taxes, equipment rental or depreciation, and marketing and advertising costs. These are all considered fixed costs since any variation is infrequent and the amount does not directly depend on the number of units produced. Okay. Now that we have all those variables in mind, let's move on and try part A of this problem. We have that the expected sales volume is 4,800 units. In other words, Q equals 4,800. And we need to find this year's net income or net profit. We need to find profit, or PFT in short. To find profit, we need to use a formula. profit determines the success of a business, and profit is calculated by by finding the difference between the total revenue of the business, that's the total revenue earned, and the total costs incurred in the business. So we do total revenue minus total costs. Now the total revenue of a business is the amount of money received or brought into the business from the sales of the items produced and sold during a period. Total revenue is calculated by multiplying the selling price per unit, so that's P, by the number of units sold, so that's Q. So here we multiply 1,780 by the number 4,800. And when we perform that multiplication, we find the number 8,544,000. So that's the total revenue earned for selling 4,800 ovens. Now the total costs are computed by adding fixed costs and total variable costs. Costs can be fixed or variable. When we add fixed costs and total variable costs, we get the total costs. And here we have fixed costs of $2,275,000 and total fixed costs of 760 multiplied by Q. So we're doing $2,275,000 with 760 multiplied by 4,800. And this number corresponds to, well, when we perform the operation, like the full operation, we get the value 5,923,000. Now with the value for total revenue and the value for total costs, we can find this year's net income. This year's net income is the difference between the total revenue earned and the total costs incurred in the business. We have $8,544,000. Take away $5,923,000. And when we perform that subtraction, we get the number $2,621,000. So that's the answer to part A. Okay. That's the answer to part A of this problem. We got to that answer by playing with various variables. We fixed the number of items produced and sold, and then with that, we got profit equals total revenue minus total costs. Total revenue was written in terms of P and Q. Total costs were written in terms of fixed costs and total variable costs. And we found the answer to part A this way. Okay. Now let's work on part B of this problem. Let me erase what I have here to move on to part B. In part B, we want to find the number of units that the manufacturer must produce in order to break even. In other words, in order to have that the total revenue is equal to the total costs. so the business breaks even, if the fixed costs are increased by 25%. I need to know the number of units, break even, so profit will be 0, no profit, no loss, if the fixed costs are increased by 25%. So the new fixed costs correspond to 125% of the fixed costs we had originally. Okay, so to work with this problem, we start by finding the new fixed costs. The new fixed costs correspond to 125% of the original fixed costs. So we multiply fixed costs, that those $2,275,000 by 1.25. When we do that, we find that the new fixed costs are $2,843,750. Now, we need to make profit equal to 0. And profit is total revenue take away total costs. So we're trying to make total costs match the total revenue. Okay. Now the total costs, remember, come from adding fixed costs and total variable costs. While the total revenue comes from multiplying the selling price per unit at which items are sold, P, by the number of units sold, so Q. Then we want to ensure that $2,843,750 plus, and here we have this value 760Q is equal to P times Q, and P is 1,780, then times Q. And we need to find Q. So we're going to isolate Q. Here we have $2,843,750 should be equal to $1,020. That's what we get when we subtract 1,780 and 760. So Q turns out to be $2,843,750 divided by 1,020. And this number is value, let's see, 2,787.9901, etc. We can round these off to 2,788 units. So the manufacturer must produce about 2,788 units to break even. Now, in most businesses, the goal is to make a profit. And to achieve this goal, the total revenue from the business should exceed the total costs associated with it. Revenue is earned from the sales of a product manufactured or produced, but there are numerous costs incurred in manufacturing or producing a product before selling it. When the number of units of the product produced and sold cover all the costs related to producing it, the business is set to break even. So the point at which the total revenue or total sales is equal to The total cost is known as the break-even point. At the break-even point, the profit or net income or loss is 0. So there is no profit made or loss incurred. To solve this problem, we made profit equal to 0, and we solved for Q, provided that the new fixed costs were 125% of the original fixed costs. We ended up with a linear equation. To solve for Q, it was enough to isolate Q. We found Q equals 2,787.9901 and so on. Because we needed to round up the answer to the next whole number, we found the number Q equals 2,788 units. Okay, that's it for this problem. Thank you very much for watching. If you have questions, write comments, and I'll be happy to help you. Bye-bye.